So today I'm going to talk you through some sedimentary rocks, and you will begin this unit immediately, but this is kind of a preview, or if you're viewing this, we've already begun this, then you'll see that we've already begun talking and using the same language. I think what's really important, I'm going to start using the textbook a little bit more to make sure you can know where to find it, but I have the textbook out. I am in chapter 3, and I've moved on to sedimentary rocks. And I think one of the first topics that you can pay attention to is that these are sedimentary rocks. They're made up of sediment, meaning we have to start recognizing that these are what we call, the first ones we'll look at are what we call detrital. Detrital sedimentary rock, if you'll see over here, a detrital sedimentary rock, let me see if I can turn this over here a little bit, simply just means it's made up of other sediment that came together. So these were fragments of rocks that then composed or re-cemented and solidified together and compressed, and then we create new rocks. So I'm going to start off by showing you conglomerate and breccia. And these are pictures in the textbook and actually happen to have samples right here. So a conglomerate simply says that the rock material that's inside here are rounded. That just tells me that the conglomerate is a conglomerate. It's made up of a lot of different rock fragments, but it is definitely detrital because it's made up of pre-existing rock. Where this one here is called breccia. These are angular fragments of rock inside here. So a breccia and a conglomerate are similar, but one of them has angular. Breccia has angular, and conglomerate has rounded pieces, both of which are detrital. These have coarse fragments of particles within them. So that's an important one. They have coarse ones. You can see them very, very obviously. But when I look at two other types of rocks, I'm just looking, these are a little bit more on the finer to medium scale. In terms of the texture, this is a sandstone, and I don't know if you can quite get, if you can see like the little flashiness, but it actually feels gritty. It feels like sand. Well, that's kind of convenient because it's made up of sand, so therefore it is sandstone. So sandstone kind of gives itself away, and I've got several different types of sandstone that you could view. And here is a piece of sandstone that has, actually that one's not sandstone. But sandstone definitely feels gritty to the touch. There we go. Here's the piece of sandstone I'm looking for. And this sandstone has very nice horizontal layers in it. And you'll see that we'll talk about how sediment gets laid down in very nice horizontal layers. So we'll talk about that a little bit. Both of these sandstone, very grainy, very gritty, feels like sand because it is. Here's shale. Shale is a very common, it's kind of a mud rock. I think over here it refers to, where does the sediment come from? I'm referring to your textbook here. Shale, it's made of mud. I mean, that's really what it is. Mud that solidifies, you squeeze out the water, and it becomes rock. Very, very fine, it's got silts and clays that compose it. Here's a type of rock. This is a silt stone. This is kind of a mud stone, and it's one of the rocks in the rock boxes. And it's got some sand grains in it. It's got a lot of mud, and just another type of clastic or detrital sedimentary rock. So we're going to keep moving on here. Let's see here. Let me turn the page. So here I've come to a page here that I'm looking at that I want to make sure that you have a chance to pay attention to. And this type of rock here is actually called Coquina. It's kind of a cool rock. It's got some of its own unique characteristics. And I have samples of this, and it looks like this, a bunch of shells. And I don't know how the quality of the viewing quality is, but it's just got a bunch of shells here. I'm on page 66 here in your textbook. And there's a couple pieces or features that I can do, and I can test it as I can drop HCl on different rocks. So I have some limestone, I have some fossiliferous limestone. I don't know how much you can see details here, but I have a fossiliferous limestone here. I've got very obvious fossils inside here. So if these contain calcium carbonate, they should effervesce in the presence of weak acid. So naturally, my first reaction is to say, hey, let's drop some acid. And if it effervesces vigorously, it definitely does. If it effervesces vigorously, and that does too, and fossiliferous limestone, it's simply telling me that these limestones are going to contain the mineral calcite, and therefore we got effervescence, vigorous effervescence in all of these. Therefore, all three of these rocks contain calcite, and that's for a very good reason. They are the remains of hard-shelled organisms, and therefore so I've got fossiliferous limestone, chemical limestone, and coquina. And these are just three different types of sedimentary rocks that have calcite of a mineral that makes them up. So as I continue moving on here, I have, on my next page, I have Flint and Jasper. These are just different types. They're pretty cool rocks. I don't have those cool of rocks, but I do have some fossilized bone. This is a nice little animal bone. That's very old. I don't have an actual date to it right here, right now. And here I have some, I believe this is chert. Yes, it actually is. It's a crystalline silica. But both of these here are the same composition here. They're just chert. They're just microcrystalline quartz, and I'm just reading right here. And that's essentially what it is. These are made for really good arrowheads from Native Americans who lived in the area back historically. So then we can talk about another chemical type of rock, and we can look at here on this page the salt flats of different parts of Utah. Here we go. Here's a map, Salt Lake City, Utah. If you can see it here. And here's a rock. This would be rock salt, perfect cube, right? We learned that halide is the mineral, that the rock itself is called rock salt, perfect cubic form. It's very nice cleavage planes. It breaks very, very nicely into 90-degree equant crystal shapes, crystal forms. So I just gave you a little walkthrough of several different minerals, several different sedimentary rocks, and talked about the minerals within them. This here is Selenite. It's rock gypsum. It's got some cool striations here. We'll talk about these in class a little bit later. And last but not least, if I turn the page to 67, next week we'll be talking a little bit more about fossil fuels. In particular, we'll be talking about coal. And coal is a primary source of energy for our nation and for the world. And this one here happens to be a fairly high-grade bituminous, maybe even as much as a low-grade anthracite. So make sure you read this page. We're going to be catching up next week. We'll go through, I've got peat, I've got lignite, I've got bituminous, and anthracite. So I've got the 4 different primary hydrocarbon sources of solid rock that we use as fuels. So next week, big week on sedimentary rocks. Make sure you are ready to rock and roll. Woohoo!